this video, we will see about conditional distribution and conditional density functions. Okay, so I'm taking first the conditional distribution. So if you observe in this particular concept, we have conditional probability concept. Okay, like P of A given B, and we have distribution concept also. Distribution concept is nothing but capital Fx of x, like this we have seen the concepts. Okay, so it can also be called as cumulative distribution function. What is the definition of this one? Probability we have to take up to x value. Okay, so probability of x less than or equal to x is nothing but cumulative distribution function that is indicated with the capital Fx of x. Okay, so conditional distribution function means it is involving both the concepts. That means this conditional probability concept is there. What is the formula for probability of A given B? We know from our unit 1, that is a probability of A intersection B by probability of B. It is giving the information about the probability of A provided B has already occurred. Okay, so when B has already occurred, then what is the probability of A? That is different from just P of A. That means I can say probability of A given B is different from probability of A. Okay, whenever B has already occurred, and if you know about that particular information, then sample space will be reduced. All these concepts we know. Okay, sample space will be reduced. But here, to calculate P of A, original sample space will be used. Original sample space will be used. Okay, but whenever B has occurred, the sample space will be reduced so that we will calculate the probability of A. Probability of A given B is nothing but probability of A only, provided B has occurred. So P of A, probability of A is also probability of A only, but we don't know about B, whether it is occurred or not occurred. We don't know about B in case of P of A. Okay, so this is about the conditional probability we have studied already. And in case of the distribution function, that means capital Fx of x, we are taking the probability for the random variable up to the random variable value small x. Okay, for example, if you take example, I am writing here, tossing coin, fair coin 2 times. Then the sample space will be involving head head, head tail, tail head, and tail tail. This is a sample space. Okay. Now just I'm defining the random variable x as the number of heads. So because it is representing the number of heads, we can tell in case of head-head condition x is equal to 2, in case of head-tail condition x is equal to 1, in tail-head also x is equal to 1, in tail-tail x is equal to 0, because no head is available in the tail-tail concept. So what are the different values will be taken by the random variable x is nothing but 0, 1, 2. Okay, and if you take the corresponding probabilities, probability of x is equal to x is nothing but, what is the probability of getting 0? 0 is nothing but what? Getting tail-tail. So getting tail-tail is just one of the outcomes out of 4 outcomes. That's why probability is 1 by 4. What is the probability of getting x is equal to 1? Getting x is equal to 1 is nothing but getting head-tail and getting tail-head. That means it is 2 of the outcomes out of 4. That means 2 by 4 is the probability. And what is the meaning of x is equal to 2? Getting head-head. Head-head is only one outcome out of 4. So 1 by 4 is the probability. Now if I say, what is the probability of x less than or equal to 0? Less than or equal to 0 means we have only one option, that is probability of x is equal to 0 only, that is 1 by 4. What is probability of x less than or equal to 1? It is less than or equal to 1 means we have to take probability of x is equal to 0 plus probability of x is equal to 1 also. So it will become 1 by 4 plus 2 by 4, that is 3 by 4. Similarly, the probability of x is less than or equal to 2, it is equal to all 3 we have to add. So 3 by 4, that means previous one, plus at x is equal to 2, whatever the probability is there, that also you have to take. That means 1 by 4, x is equal to 0 probability, x is equal to 1 probability, and here x is equal to probability also. That means 4 by 4 is equal to, we'll get 1. Okay, so if you, this is the concept of the what we can tell this is a probability distribution function or cumulative distribution function. This is separately I have told here, and this conditional probability concept also I have given separately. Now these two we have to merge, okay, into the only one concept called conditional probability. So conditional probability, that is given by probability of A given B is equal to probability of A intersection B by probability of B, and cumulative distribution function is nothing but capital Fx of x is equal to probability of x less than or equal to x. Now you see in the previous table x is taking 0, 1, 2 and corresponding probabilities are given like this: 1 by 4, 2 by 4 and 1 by 4. Okay, so what we are doing in the sense, we are merging these two concepts. So in order to talk about this conditional probability concept, here two events are required. Two events are required. Those are A and B. A and B are events or subsets. We know about those concepts. I am not repeating those concepts here. So sample space is involving so many number of subsets. We can able to make so many number of subsets from the sample space, and all those subsets can be taken like a events only. Those two events are here, A and B. So to provide the conditional probability concept, we need to have two events, and here we are talking in case of the cumulative distribution function, we are talking with respect to random variable. But if you say x is equal to 0, it is also event only, because it is representing tail. It is one of the events of the total sample space. And x is equal to 1 means it is also event. It is representing tail head and head tail. It is also event. X is equal to 2 means it is also event. X is equal to means it is representing head head. Not only these three, if you take x is less than or equal to 1, it is indicating x is equal to 0 and x is equal to 1 also. So this is also event because it is representing tail tail, head tail and tail head. So this is also subset of the sample space only. So whether you are telling simply A, B, C, D like this, all these things are events, or if you say x is equal to 0, x is equal to 1, or some condition if you provide with respect to x, all these things also events only. So now what we are doing in the sense, if you use random variable, it is including the concept of the distribution. It is including the concept of the distribution or density. If you use simply A and B, we have defined already conditional probability. Conditional probability we have defined with respect to the events A and B. Just we are taking one of the event out of A and B as the random variable concept, or two events also you can able to take. Now for simplicity, just I will replace the event A in the conditional probability with the random variable concept. Then how we can able to write, you can able to see here. You see, conditional probability means we have to write probability of A given B. Just in place of A, I am going to take the event x is less than or equal to x. That is, x can be 0, 1, 2, 3, whatever it may be. Okay, depends upon the experiment. So I have already understood that A is the event and x is less than or equal to x is also event only. Or x is equal to some 1, 2, 3 like that also, those are also events only. So in place of just A, I am introducing the concept of the random variable, so that I can write the conditional probability like this. The conditional probability of, in place of A, I am using x less than or equal to x. This is the event. This is one of the events. Given the event, another event, I am taking B only. So now you see this representation. In place of A, I have taken the random variable concept. So I am introducing the distribution or the density concept into the conditional probability. So how to write this one? Now you don't think about x less than or equal to small x, all those things you no need to see. Just you apply conditional probability concept, where in place of a, just we have taken x less than or equal to x. So x less than or equal to x is the event, that's it. So how to write the conditional probability formula? When probability of one event given another event is there, how to write the formula? Probability of the intersection between the two events we have to write. That means first event is x less than or equal to x. This is the first event. It is in intersection with the second event p. So x less than or equal to x is the event, divided by what we need to write here? Probability of b. That's it. Okay, this is called conditional nature is available because given b is there, and distribution nature is available because here x less than or equal to x is available. And this entire thing we can able to represent using, because it is involving the distribution nature, because x less than or equal to x. Okay, because of the presence of x less than or equal to x, I can tell it is having the distribution nature, so that I will represent capital F. And it is defining for the random variable capital X, that's why here capital X. Then here how to write small x given b, because it is involving conditional probability nature and distribution nature for the random variable x, so that I have represented like this. So this itself is conditional distribution function. Conditional distribution function. Now we'll see how to write the conditional density function. Okay, conditional distribution function. Just now we have represented with the capital Fx of x given b, that is equal to probability of x less than or equal to x given b. Okay, it is equal to probability of x less than or equal to x is one of the event, intersection with b by probability of b. Okay, then we will write about conditional density function. Conditional density function means we have to represent with the small fx of x, small fx x given b, same thing, because it is involving conditional probability, that's why given b we have to take, and it is a density function, that's why we are representing with small f. It is equal to what operation we have to perform on the distribution to get the density? Differentiation. So d by dx of capital Fx of x given b. That's it. Okay. So this is the concept of conditional distribution and conditional density function.